I explained it to you that wait a second, did I send? Yeah, I did. Okay. And did I send it here? I did. Okay. So in this particular question, I said that so suggest and explain how the apparatus in figure 3.1 could be modified to make the peak on 3.2 flatter without significantly changing the frequency. The only way you can change the frequency significantly if you cause heavy or critical damping. All right, everyone. So it means that now when you're looking at this question, you see that here it is moving up and down. So I could attach some feathers along with it. And when I attach the feathers, then it's going to help me with, you see, getting like a flatter peak, but it won't be shifted from the natural frequency. Do you guys understand? Because the density of the overall system is not going to change. All right. So that means if I want to write it for 3 marks, then what would you do? You would say that V.1, we can add feathers those will increase the damping third, since they do not add to mass significantly, it would not alter the natural frequency F naught. Do you guys understand now? Any questions? Amal,
Sir, feathers
yeah.
how? Or like where did the feathers come from?
Sorry? Uh,
Where did the feathers come from?
I don't understand what you're saying.
In the first point you wrote that we can add feathers. So
Yeah.
like how did the feathers come? What do you mean by feathers?
When you add feathers, right? What feathers do is they increase surface area, right?
Yeah.
Which increases air resistance when it's moving, right? That's why. So that will cause damping, right?
Oh, okay.
Do you understand?
Yes,
So
sir.
this is how you deal with these questions when they want you to know add something and not significantly change. If they had said, okay, we want to significantly change and we want massive damping, then obviously you would choose between heavy or critical, depending on the situation. Okay.
Yes, sir.
All right. Then going to this question. All right. So this is basically electromagnetic induction. I want you to do this, but later on. So I'm writing after completing induction. We'll come back to this and you can do it. If you still know this, obviously, a lot of people have, gone through this syllabus once with me. So they can do this, obviously, as a homework. This is very simple. You guys can actually look at it. It's no big deal. Same goes for this one. This is also because some questions are like repeated. So this will also be a homework. But I just want to tell you, I just want to, put your attention towards this. If they say the magnets brought rest in voltmeter replaced by variable frequency alternate supply, and now they say that basically the frequency of size gradually increased from this to this, where F is the natural frequency. So you want to add to axis. So basically you need to know that at natural frequency it will be highest, and you will start from here, go to the peak, and then decrease like this. All right. So you just need to draw this graph, and this graph is the same graph as in the previous one. So you can always, I'll just copy it from here. So it's fine. Okay. Do you guys understand this? So this is just the typical amplitude and frequency graph that we have drawn a couple of times, and I expect you guys to do it again. Okay. Now,
So the graph stays the same for all the questions, right?
yeah, it stays the same. There's no change.
Okay.
Yeah. Anyway, then says name the phenomena. State one situation phenomena is named is useful. Okay, so again, if let's suppose it says we want to the phenomena is obviously resonance, right? And state one situation where the phenomena named is useful. So those questions where they say, okay, where is resonance useful? Um, the best thing is that you just remember that, okay, I am going to in sort of systems where you need to increase the energy. Okay. And those systems, so let's write here, add that when it is useful and when it is not useful. Okay. Add to this so that we can, be sure of it. Couple of things that you need to remember. First of all, resonance is definitely useful in producing ultrasounds. Okay. Number two, it's also useful of quartz crystal timing. So it's basically another way to basically produce ultrasound, but you can write either of these. When it is not useful is basically in vibrations caused in buildings, bridges, vibrations due to wind, and car suspension. So it is not very useful there as well. Is that clear, everyone? You can
Yes,
also
sir.
write railway suspension, something like that. So right now, if they say it's useful, just write that production of like ultrasound. And they will never ask you more than one. So that's a good thing, right? So you can just remember this and always write when they want to do this. Okay, so it's production of ultrasound. All right, that's where resonance is used. Anyway, then we go to this question where it says that there's a tube, there's sand, and it's being displaced in liquid. It says determine for the oscillation tube the amplitude. So obviously, we're going to find what is the middle of this. So I think it's 15.5 and this is 16.5. So 16 would be the middle. And then you just need to see. So it's basically 0.50 centimeters. Then the period, you can go from here, like here, and you can go till here. And I don't know what that is, you know. So this would be 0.5. So this will be 0.6, 0.7, 0.8, 0.9. No, I guess that's wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is 10. 0.6, 0.7, 0.8. So this is 0.8 and 0.80. So tube at point where the depth is 16.2. Now we need to basically see this depth because this is the depth. 16.2 would mean that this is like 16.5, 16.2, 16. Okay, wait. Oh no, that's not good. Let me see. Okay, am I lagging now? Radhika, is it okay?
Yes, sir.
Javeria late, very bad. Okay, now,
I'm quite sorry, sir. I was asleep.
yeah. So then 16.2 would mean that this point has to be like here. So the displacement at this point is basically 0.20. That's the displacement, right? And we want to find the vertical speed. Do you know what is this? What is the formula for finding speed at vertical displacement? You guys don't know. That's very bad. You forgot this formula already? Okay. So you have the time period. You simply need to do 2 pi over 0.80. You have the amplitude, so 0.50. Because it is in centimeters and we also need answer in centimeters, so we're just going to keep it like this. And this is 0.20 whole square. Can you please find this value? Yes, please.
3.6.
3.6 centimeter per second. Okay, very good. Now it says state one depth where speed will be equal to this. Obviously, this, and if you go down the same way, so 0.2 minus 16 would be what? 15.8, right? So we can say at 15.8 depth, it would be the same, but in the opposite direction. Do you understand? Because the displacement will be the same, but just in the opposite direction. So it will just give you the negative value.
Yes, sir.
Okay. All right. So then what is meant by damping? Who knows? Damping is?
Sir, which page is this? I'm so sorry.
It's basically the place where I've written damping. Okay. And then you're doing the next question. Julia, here?
Yeah, okay, I'm
Can you come?
searching. Okay, found it, yes.
Okay. So, now we just decrease in energy. All right, I'm sorry. My phone decided to update just now and the hotspot just went away. Sorry. All right. So then damping is the decrease in energy. And right now, caused by an external force. Okay. So you write decrease in energy for 1 mark, and then you write caused by an external force. Right now, if you look at the situation, if it's oscillating in liquid, what was the external force that causes something to slow down? Do you guys know that?
Air resistance.
In liquid, is there air resistance?
The
Upthrust.
upthrust.
No, upthrust is always constant. With respect, I mean, it could change with that. No, it could be drag or friction. All right. So you can add that if you want to make it a better answer. Is that clear?
So instead of external, we can write resistive force.
Yes, you can write resistive force. Resistive force is always external force. That's why. Okay. But you can write that. Any questions now? Now, in the next part, it says the liquid is now cooled. So, although the density is unchanged, there is friction between liquid and tube as it oscillates. Having been displaced, the tube completes approximately 10 oscillations before coming to rest. On figure, draw a line to show the variation of time t and depth t for the first 2.2 seconds of the motion. So we need to basically draw for first 2.5 seconds are here, I believe, somewhere here, right? So you just need to draw this and gradually decrease it without changing, like we have done it so many times. All right, is that clear? Do not change the time period. Okay. Any questions now?
No, sir.
No, sir.
Good. All right. Finally, we go to the last section where we will study about this graph. So in this part, can you guess what is shown here?
They're showing us resonance.
Resonance. Very good. It's resonance. And then it says for maximum amplitude of a state, the magnitudes of amplitude and frequency. So the maximum amplitude is at the peak, and that would be, I think, 16, है ना? 16, 17, 18, 19, 20. So 16 mm. And the frequency there is basically this one, which is, I believe, if this is 5, then this will be 4.2, 4.4, 4.6 hertz, right? Okay. Aman, do you understand this? Arsalan, Fahar, Nadia,
Sir, I
Kafir?
don't understand how it's 4.6 hertz.
At the peak, right? This is where the maximum displacement is, right? So I need to check the frequency at that point. So I go down, I check this point. So it's basically, you see, from 4 to 10, there are 10 boxes. So in the middle, 5 is 5. So each box will be
Okay, got it, got it.
4.2, 4.4, 4.6, like that. All right. Now, then say the oscillation of the metal cube is 150, may be assumed to be a simple harmonic. Use your answer to determine for the metal cube the maximum acceleration. So maximum acceleration formula is, who's going to tell me that? A
Is equal
equals
to
to
negative omega
minus
square displacement.
X.
Negative omega
Okay.
square x.
Yes, negative. So we have the frequency, right? Can we do 2 pi f whole squared times x naught minus 2 pi 4.6 and this whole square, and the maximum displacement is 16. We need it in meters, right? So we're going to change it. 16 times 10 raised to minus 3 to change it into meters. Can you please find this? Why? Why? It's this
0.46.
yeah, 0.46 meters per second, right? Negative. So because it's talking about maximum, so you can write negative 0.46, right? Is that clear? Then he wants to find the maximum resultant force. Do you know any connection between resultant force and acceleration?
Sir, I didn't get the same answer for acceleration.
What you get?
I don't know, it's negative 13.4.
Are you sure?
That's what I got.
Gatika? Let me check. Let me check that. 2 times, sorry, 2 2 shift pi times 4.6 whole square, right? Times 16 times 10 raised to power minus 3. Oh, yeah, it's wrong. It's 13.4. You guys, 13.4, right? Is that clear? I think it's clear. All right. Now, so we have the mass, which is 150 grams, and we want resultant force. So 150 would be 0.150 in kg and 13.4. Can you find the magnitude of force, please?
2.0 Newton.
2.0
Yeah.
newtons. All right. Now it says some very light feathers are attached to the top surface of the cube, so the feathers extend outwards beyond the vertical side. Investigation now. On repeated, draw a line, new variation of between 2 to 10. Now, if you add feathers, what will happen? It will cause it to have smaller amplitude now because it will damp it, right? So how will we show that? We're going to start from the same point, and then we're going to just make peak slightly smaller and then line underneath this. Is that clear? So this will show basically light damping. Okay. Any questions?
No, sir.
Okay, very nice. Then, and that's it. We're done. Okay, cool. So we finished with this chapter, and I believe if you guys now try to complete the PDF today, um, that would be very nice because this is a long one. Should I upload this? I think I should upload this, you know.
So you can upload it and you can increase the deadline.
Increase the deadline. The deadline is
Time.
Friday.
Yes, so you can make it like last time Sunday or
Sunday. Sunday would be acha, chalo.
please.
Okay, okay. All right, fine.
Thank you.
So I'm gonna put it on here. A2. Okay. So the next chapter, I don't know which is the next chapter. Ideal gases, probably. Okay. A2. Make an announcement. So this is like the complete PDF solved. Those who came late, they can also, go through this, work it out. Very nicer, actually. Oscillations. Okay. All right, please complete your work today. So, and on Monday, we are going to start with ideal gases. And now it will be much faster because the topics are much smaller. Okay, I hope to see you. Why are we finishing the class so early today?
I was about to ask.
We have nothing to do really. Okay. So do you guys want me to explain anything? Anything else? Any questions you have? Any homework from school? I'm so free.
If you could give me 1 minute to think.
Okay.
Sir, the graphs that you showed for when you showed the net graph for WRT frequency, what does WRT mean here?
With respect to?
Oh, with respect to. Right, thank you.
Yeah. All right. I know what we're gonna do. So because we have time, how about we could just simply, I'm gonna stop this recording